Misalignment. Misalignment occurs when the shaft center lines of two directly mating components meet at angles and or are offset from one another. It is of two types: angular misalignment and offset misalignment. The common causes of misalignment are thermal expansion, most machines are aligned cold, machine vibrations, forces transmitted to the machine by pipe or support structure, a soft foot, a direct coupled machines are not properly aligned, and poor workmanship. Angular misalignment. A typical FFT generated by an angular misalignment is shown here. The shaft center lines intersect but are not parallel. Angular misalignment symptoms are a high axial vibration at 1 into RPM, possible harmonics at 2 into and 3 into. 2 into RPM axial components may be as high or even higher than the 1 into component. Radial vibrations probably lower amplitude than the axial at 1 into, 2 into and 3 into RPM. The radial vibration will depend on where the shaft center lines intersect the assembly center line. Axial phase across the couplings shifts significantly, that is greater than 60 degrees. Shaft center lines intersect at the coupling. Note the absence of coupling movements and the high radial and axial bearing movement. Shaft center lines intersecting at the bearings. Note the high radial coupling movements, the low radial and the high axial bearing movements. Offset misalignment. Offset misalignment's symptoms are a high residual radial vibration at 1 into RPM, harmonics at 2 into and 3 into RPM. 2 into RPM axial component may be as high or even higher than the 1 into component. Axial vibration probably lower in amplitude than the axial at 1 into, 2 into and 3 into. Radial phase across the coupling shifts significantly, that is greater than 60 degrees. Axial phase across the coupling shifts significantly, that is greater than 60 degrees. The animations on the right hand side would make it easier to understand.